Hi, thanks for joining. So this is another Thank God It's Kubenet session on the 20th of February. So in this session, we will discuss some enhancements we did in SDC. And I will share my screen. Or I'll try to share my screen. Here's the button. And time screen. There you go. You see my screen?
Yep, I can see.
All right, cool. So yeah, so we did a few enhancements so far. So not everything is in yet, and I think we still have to label the build, Marcus, right? So, so I'll go. So the idea is to give you an update on the differences. So we have a few elements. One is discovery. So we made discovery more flexible in the sense that before, to add a vendor, we had to write code. So that is gone. Then we have added the ability to orphan resources. Sometimes people want to delete a config, but do not want to delete it from the device. So there is a capability to add add configuration knob to allow for orphan deletion. And then we have added a dry run element. And then so there is some, so we had to do quite a few changes. So we actually made a fork of Goyang at the moment because we have some backward incompatible changes and we saw some issues with respect to Yang. And then so Marcus did a lot of work on defaulting as well, right? And then we internally changed, we'll talk about that, so between the config server and the data server, we actually use gRPC. And so we changed it to a transaction interface that sets us up to do that, let's say, rollout and the actuator-based design to then, so this basically sets us up to be able to do network-wide transactions, right? So let me go into them one by one, right? So first of all, so there is discovery, right? So if you look to what we do today in discovery is that on one end, so there is basically two steps somehow, or there's two phases. One is we have to identify the IP address and host name of the device, right? And so we have various mechanisms to do so. One is an IP prefix, so you can give it a range. You can give it a dedicated IP address, or you also we have discovery within Kubernetes. So that's really if you really deploy it within the Kubernetes cluster itself for pod and services. So we basically discover the IP address, or we get the IP address and host name from there using the DNS name. So that's the mechanism. And then so the thing that we really changed is the second phase. Is that once we know there is an IP, we want to determine the provider and the version that sits behind, right? So the provider, at the end of the day, is the vendor NOS, right? Because if you look to if you look to Nokia, we have two NOSes. We have Azure OS and we have Azure Linux. So a provider is actually a representation of a NOS of a particular vendor, right? And then we have, so we also discovered the version that NOS is running. And so in order to do discovery, we have a thing that called no discovery, or what I call the default schema. So you can basically hard code it into the discovery rule. And as such, we do not actually do discover it. So we just assume what is in the configuration. But so the thing that I think is most interesting is that you actually do discovery in a vendor agnostic way. So we introduced a concept of what we call discovery vendor profiles. And I'll talk about that in a bit. So what they are, so they are templates, if you will, that have a set of artifacts to be able to then have discovery done in a vendor agnostic way. Now, one important element is from the moment you run this release, if you do not have these profiles configured, your discovery will not work. Or you will not discover devices because the code that was before, let's say, compiled is removed, right? So that means that even for the Nokia devices, we actually use these profiles. So how do these profiles look like? So first of all, what is important is that I decided to make the name. So the name that you put here is going to be used as the provider name, right? So that's one. I could introduce another field, but I thought it was so much in direction that it's too much, right? So that's important. And then what we have right now is we focused on GNMI because that's what we had. So, but the idea is to also add netconf or other mechanism of discovery going forward. So there is a GNMI section, but the idea is if you have netconf to have a netconf section and so on and so forth, right? And so what we did is we basically, so there is also, again, two phases in this step. So one is we just try to determine what is the NOS. Actually, we try to determine what is the version and what is the NOS that sits behind. And of course, in Arista, there is a single NOS. So in other words, the organization tells you the NOS, right? Whereas in Nokia, you have to go one step deeper, is that you have to look into the details that you get. So we use GNMI capabilities for this. So when you do GNMI capabilities, so there is an organization field for the models. So we use that. And then the second thing that we do, so what you see here is as organization is actually matching the organization in the capabilities that you get. And then there is a model match. So you see in the case of Azure, OS, which is this one, yeah. So you see, and so this is the one for Azure Linux. So you have a different tagging here, right? Or a different model match here. That basically, so that's the one that distinguishes between Azure OS or Azure Linux. And of course, in Arista, or if other vendors do not, they only have a single NOS, you can do it with the organization. Okay. So that's the first step. So as such, we can discover what is the provider, and then the second thing that we do is we do GNMI gets. We can specify the encodings that you use. So by default, we use JSON IETF because we see that that's used across the board, right? But we could use also Protos, JSON, and ASCII, I think. Yeah. And then what we do is so there is always this key. So this, if you see, so when you look at the target, so these keys, they match the target information that is being discovered. The only one that is really important is the version. All the rest is metadata that is interesting in the target. So if you look, let me go to a device on my, yeah, I'm debugging something. So let me take my thing. kubectl get targets, right? So you see, so what I was referring to, so the IP address, so IP address you always get, right? But platform and serial number and MAC address we don't really need, but it's just nice to see that if you are debugging, right? And I only have SRL here at the moment, but Hans tested this with Arista and Azure OS. We didn't test with others at the moment. But yeah, so we look forward for people that if you want to add other NOSes, we can now do so by adding these paths. And so basically for version, typically you have, so we have two ways to parse the data, because what you see is that, for example, also for Azure Linux, right? So you get these, if you do, so basically, let me first explain how it works. So these are GNMI gets. So there is a key that is matching these fields that you see in the targets that I was showing before, right? Platform, serial number, MAC address. So these are the ones that we have. So these are these. And then, oops, sorry. So for each of them, oops, we have a a path, right? So this is the path that is relevant for the particular NOS, right? And then we have, so we can use regex expressions to manipulate or transform the data that you received. So we have two mechanisms. So we have regex as well as starlark, which are Python scripts that you can use to transform the data. So, but typically it's a string to a string. So far we have seen that with regex, we have sufficient capabilities to do so, right? But it might be that you need some other capabilities. So as such, you don't see it because we didn't need it. There is a script as well in the CR that allows you to build a Python script, and then you can then that will be executed. So, and the sequence is first regex and then script. So if you need both, you could so you could have both in sequence if you want, but that's probably a little bit too advanced. Yeah. So basically, yeah, with this you can be flexible in the discovery. So because we now, as you can determine the path. So the keys here, I made them flexible. So we could have also hard coded it. And the reason I did it like this is because we could have, so let's say if we want other data later on, it would be easy to extend, right? Without changing the CRD. But these keys are kind of hard coded, if you will, right? So that's the thing. But so yeah, by adding the paths, you can now, I tell the system, go and fetch these, and the data, so the thing that we retrieve from here will be added to the target discovery. So when we create a target after the discovery, that data will be added into the fields, and you will see that when you display the target, right? Here are examples of Arista, right? And an example of Azure Linux. So we tried all these three. So these are the paths then that you gave us, right? This works. One gotcha that we also saw, which is typically for Azure Linux. So what is nice is that sometimes you want to use these paths or specify these paths without keys, right? Because it might be that in one system, for example, if you have a modular system that you have a slots, so certain slots populated, so it's nice to, it would be nice to specify them without keys. What we've seen in Azure Linux is that they return, if you don't specify the keys, you return a big JSON blob. And we decided not to process the JSON blob. So now we specify a key, right? But so if you want to do it without keys, for example, using Proto or ASCII would also work, right? So yeah, I don't know whether there's any questions. If people are interested and want to use other NOSes, actually by using this field, you can actually add Juniper or Cisco or other NOSes if needed, right? All right, if there is no question, I'll go to the next topic. So the next topic is orphaning configs. So basically, so what we typically do, so some people have requested us to have the ability to not delete the config from the device, and when you delete it, but leave it there. And so the way to do so is in the config CR. So this has been there for a while, but actually we never wired this up properly. So if you want that behavior, what you do is you specify this lifecycle with deletion policy, and you put it to orphan. By default, it is delete. So there is two options, orphan and delete. And if you specify to orphan, what will happen is that when we delete the config from the data from the system, but we do not delete it from the device, right? So
I'm
that's
just trying to, sorry, just a quick question. I was trying to get my head around what would be the use case for this.
So for example, some people have like, for example, if people would basically take running config, right? So all the base config onto their system and make a CR to have no unmanaged config, for example. and you would delete that CR, that means that we delete also all the SSH keys and everything, right? So you cannot access the device. So what would be, right, so what you could do is basically add that to an orphan scenario. So that's one use case that I know of. I think the people from Swisscom had another one, but I don't. Marcus, do you remember?
No, I don't remember. But yeah, I mean, it's a little counterintuitive to what we're trying to achieve with the whole system, right? But yeah, some people came up and were like, okay, if I want to unmanage this bit of configuration, but yeah, prevent SDC from deleting it from the system itself, is that possible? And yeah.
Okay, right. So it's something that became managed, but then you want to actually unmanage it.
Yes.
Yes.
Yeah.
Okay.
Way like, okay, leave it on the box, but like not have an intent for it. Then you,
Okay.
then you add this flag, and then delete it, and then
Yeah. No, that makes sense now.
Yeah. A typical example is running config. I like the full config or something like that. If you really want to, or another piece of config that you want to stay, keep there.
Yeah, I suppose if you kind of got all the running config and went through and managed everything, but then thought, oh, actually, this part of the config I don't want to manage anymore. I'd rather just leave it unmanaged. Then then you do this.
Yeah.
But then presumably you would do this. Or you can leave this config file there in the data store, right? Like once you've executed this once, do you then need to actually keep this YAML file, or you could just get rid of it, I guess?
You can get rid of it, because what you will see in that case when you do this, you will get unmanaged. So you will get either unmanaged config or you get deviation, but typically unmanaged configs deviations.
Yeah. Okay. But if you just reapplied this again, it would do nothing, I guess.
In that case, it would do nothing.
Yeah. Okay. Yeah, makes sense.
Yeah. So Hans in his CI pipeline, right? So what he is going to do is he's adding running config, right? And then as a base configuration with a very low priority, right? But he never wants to delete it. You see, so he wants to remove his unmanaged these deviations, and then so he's going to use it in the CI pipeline for us. Unfortunately, he's ill, so he has been doing. Yeah, so there's a few tests. That's why we haven't fully released everything yet. Yeah. So the other thing that we did, which is also, I think, nice, is that I think this, I'm not sure whether this worked before, but we are sure that it works, or at least the test that we did seem to work right now. We have the dry run flag as well. So with this, what happens is that you can actually do a dry run. So the config the snippet that you push onto the device is not stored in the config server either, but it's a way to validate that your config is okay without applying it to the device.
Yeah, I think I did try this, but it wasn't working.
Yeah, correct. So I think and so we have the offline. So we will have multiple modes in the system, but the code is always the same, right? So if we have to, we also have this offline mode, which actually is the same code, basically. But yeah, so this you can do that in a live system as well, right?
So this would do all of the validations, everything, but just not actually transact to the device. It would do everything else.
Correct.
Yeah. Great.
Yeah. So here you see, I put here a config snippet where I changed the thing to enabled instead of enable, right? And then, so this is just the error that you get back. But so this was a simple case, right? But it works, for the whole thing. Yeah. I think this is nice. This was always on the back of our thing, but so the reason why we did all of these type of things is we changed the interface between the data server and the config server towards what we call a transaction-based interface. So before yeah, so it was, the interface was called set intent. So it basically says it was a unary RPC. So this is also unary RPC. But here, what happens is we actually have to do a confirm and a cancel of the transaction. And this is really to prepare ourselves for the bigger play that we are going to talk about as well, is to have this actuator that is doing network-wide transactions. So at the moment, the system between data server and config server are, let's say, using this at the moment. And by doing this, we actually looked at these, let's say, corner cases that we had before. And we also now enabled the orphaning and the dry run. So this was related to that. And so this is now completely wired. And yeah, and checked. And we have done some validation tests and stuff like that around that. The other side effect of this change that you will see is that before, so data server, when it was doing validations, what you see is that on one hand, we produce errors, which are really failures. But some systems like Juniper, they generate warnings. So it's not an error, but it's actually, it's good to be aware about, right? Also with this new interface, we bubbled this now up into the config. So in other words, you will see in your condition, so in the config snippet or config set, you actually will see those warnings. So in other words, we have so the whole error handling and warning between data server and config server is much better right now. And so all these errors that you will see and all the warnings. So yeah, one thing that we see, and that's not something we can solve actually, unfortunately, is that when you use gRPC and you get an error, the data is not sent. So we have so of course, if you have an error, so what it means in essence is that if you get an error, you will see all the errors, but you don't see the warnings unless the errors are gone. You see? That's a down. But yeah, we've seen that both in the REST call as well as in gRPC calls, you have that behavior. So that means that warnings are actually a bit suppressed until the error is gone. So there are scenarios where you will not see the warnings unless there is no error. So that's not something we have to change the gRPC interface or the gRPC code if you want to change that. So that's a little bit too much. Yeah. But yeah, so basically the errors and warnings are now also much bubbling up across the chain, and you will see them being reflected in the config sets. If there is an error, you will see it immediately in the ready state. So that means that in case of warnings, we do not fail, right? So that means, and maybe there's some enhancements that we need to do, is to indicate that there are warnings, because we will determine through the ready condition that the config is ready. So in case of warnings, we actually have applied it, but there are warnings. So there is extra, so there is some warnings into the system that we want to be aware about. So I probably need to do something when you do, I don't know whether I have a config. So what I'm talking about is if you do kubectl get configs, I think I have a config. No, I don't have a config. Is this the? Yeah, I am. Wait a minute, 1 second. I'll fix it. I'm debugging something, and then. I think this will work. Yeah. So what I'm talking about is that if you, so we will, so in case of warnings, we will have a ready, we will have through here, and here we have ready, but maybe I will make here a warning sign that it's actually, it's ready means it's configured, but warning means there is something to be, to look at. So you will have to look into the CR because there's too much data typically. So it's like it will blow the whole screen, but at least I will, instead of ready, if there is a warning, I will add here a warning reason. Probably that's reflecting that there is something to look into. Right, if that makes sense.
Yeah, so these warnings are coming from the device itself for whatever reason.
Yes.
It's not stopping you from making the configuration, but yeah, it's just flagging something up.
Yes, correct. We've seen it mainly with Juniper, right, Marcus, that we had these warnings that we somehow said we need to bubble this up because it was just a log in the data server. And okay, that's okay, but most people don't look at logs, right? So it's kind of, it might have been missed. So we decided to bubble this up all the way to the configs. And then, yeah, I think we need to pay a little bit of attention to it. So there's a way to achieve that. Yeah.
Mm-hmm.
So yeah, so that's not yet there. So I'll have to I'll have to add this warning thingy, but that's not a big deal. Yeah. Okay. Yeah, so that's kind of a little bit the enhancement we did. Yeah, so for example, all the issues that you found then, right? So the thing with SRL, so we had to change the Goyang and we had to fork it to be able to add deviations to the system because we saw that when we were adding the deviations to fix the schema errors, this was not working, right? So as such, we had to fork the Goyang code in order to be able to allow these deviations to be added. So that's there. Unfortunately, Hans got ill yesterday, so he was testing all of it. So we are validating it, so we will release it, but it's not everything is completely validated yet. So we are, when Hans is back, hopefully he recovers soon. We will potentially add deviations and stuff like that. So we are going through the process to add all these schema issues to the deviation lists in order to let's say correct the schema issues, right? But we will, I think, Marcus, you still have to tag the data server, right? Then I'll make a new version available. So the config server is already tagged with 74, and then I updated the docs, so we will release these code, let's say today or tomorrow, so that you can play with it, right? With all the changes that we said.
Yeah, for me, yeah, I'm actually away next week, but then the following week when I come back, then I'll have a look at it again. Yeah.
Okay, yeah, okay. So then we don't have to hurry. Yeah, if someone else wants to do some testing or not, because otherwise we'll wait. Then we will fix. It's less work, so then we will wait till if people can try it, then it would be better. Yeah. Okay, then we will wait a little bit till we have validated, because we are. So Hans was going to test through all the to all kinds of complex configurations and stuff like that, but unfortunately, he got sick, so that didn't happen yet. And yeah, maybe there is still something that we haven't covered that we need to add to our CI systems. So that's still pending at the moment. All right. So yeah, if there is no further questions, so then we will delay a little bit, and then yeah, we'll release it as soon as we have done those validations. Yeah. So maybe yeah. So the thing that we then discussed. So we discussed last session the actuator, right? So I have made some progress. It's not 100% there yet, but because of the fact that we have now this transaction interface between config server and data server, I'm going to in the next week or this week and next week wire this up. So what have I done so far? I want to share a little bit let's say the architecture that sits behind. So first, I believe we will have 3 controllers. So the first one I did not implement yet. So maybe we'll discuss that in a bit. So the way at the moment the system works, so I decided to go for the workspace name, right? So there is basically, so the idea is to have 3 types of controllers. So one is Git that takes care of, that determines, so for example, if we want to have an interface that we want to look at comments, or we would have a webhook and stuff like that, right? So that would be what the Git controller would do, is look at Git events, not necessarily the repo itself, but really webhooks that could trigger us for approvals and what have you, right? So that's why this element is there, but I didn't focus on this one because at the end of the day, this one will update the workload or the workspace CR that this guy is acting upon, and it will change the reference of the Git, let's say, repo that you are using, and then the rest kicks off. So at the moment, so I've been focusing on the workspace controller and the rollout controller. So the workspace controller is the one that will be triggered through the Git controller, right? And there, so he acts on a workspace CR. I'll show you in a bit how it looks like. So it's actually very simple. And then based on the work that he sees, he will actually trigger a rollout. And so he adds a rollout CR into the system, and then the rollout controller will implement the rollout strategy, right? So that's a high-level view of how it works. So what is the workspace controller doing? So here you see an example. So what you have here is just a repo, so URL, and a reference. And you can have different kinds. I use hashes for the time being, but we support others as well, right? So what the workspace controller is basically doing, it's checking, it fetches the the data that is in the Git repo, and it then will look at, is there a change or not, right? And if so, it will also determine, and I still need to decide whether the roll, so there is 2 scenarios in essence. Either you roll back, right? So you go back in time, or you go, you roll forward, right? So typically, I think we agreed for now to use a branch-based architecture. So in other words, by having a new branch, you do a roll forward. So you first try to actuate it, and once the branch is, once it's implemented, the branch will be merged into main because it solves, it has less merge conflict issues, right? So, but this, the workspace controller doesn't care at the end of the day about that at the moment. So in other words, you get a new reference, and it needs to know roll back or roll forward in essence, because my view, and that's also good to get feedback, is that if we do a roll back, so meaning you go back in time, it should always be a network-wide transaction. Whereas in roll forward, so the way it is envisioned at the moment is that in the repo itself, where you hold your configuration, you can add a rollout CR in that repo. And if it exists, it is taken, it is used as the rollout strategy for roll forward, right? Now, if you roll back, I don't think we want to use that CR, because you actually want to go back in time. So you want to get to that state as soon as possible. So as such, I'm of the opinion that if you roll back, you should not use that CR, but you want to get into that previous state as soon as possible, right? Whereas if you do roll forward, the idea is if you put that rollout CR there, we will use it. If it's not there, we will do a default. And I selected right now to do network-wide as a default. So you have a way to influence how a change gets rolled out, right? And what strategy that you use. And the second thing that the workspace controller does, then it will report the status. So in other words, what will happen is you update this thing, right? Which I envision to happen through the Git controller. It will fetch the repo, but it might be that the rollout is still busy, right? So I made some let's say, concurrency and some scheduling effect in it. So in other words, if the rollout is still busy, I don't do anything, but from the moment the rollout is finished, I'll schedule this new work, right? So the latest work will be scheduled. And so it does that by adding a new rollout CR or updating the rollout CR that it created before, right? So that's basically, so it's actually very simple. And I like to divide and conquer and make things simple because then it's easy to debug and easy to update in case of changes, right? So that's what this controller actually does, right? So it fetches the repo or all the changes related to it. It will update the rollback CR depending on where or how you did the change. And then it will report how it's going, right? Then the rollout controller, so I don't have too much. So it basically acts on the rollout CR, which was created by the workspace controller, and it executes the rollout strategy. So what first of all, it does, it determines the changes on the device. So in other words, if you start from 0, there is no config snippets. So it basically takes everything that was in Git and it applies that on a per device by device basis. So what it first does, it basically determines the artifacts that needs to be applied on a per device basis. And then it starts executing it, right? And the way it determines the changes that needs to happen per device is by, on one hand, looking at your, in this case, the source of truth is Git, right? But it compares it with what's in the config server itself, right? Because if you succeed in your rollout, what will happen is that these config snippets will be applied to the cluster, but they will not be applied as long as they didn't succeed. Okay, so in other words, if you had config, what would happen is, for example, you deleted a config that was no longer there, or you did an update, so it will determine whether configs needs to be deleted or updated and so on and so forth. So it basically assembles that on a per device basis. And then depending on your rollout strategy, so if you do network-wide transactions, which is the only thing that I've implemented right now, it will in parallel execute this on all the devices. And if one fails, it will roll back, right? If they all succeed, it will apply the changes to the config server. Right? So basically, then it will store the manifest and report that it's okay. If there is one failure on one device, and here, this is where strategies are going to be important, because we can determine when and what is good and what is bad, right? At the moment, it's all or nothing, just to make it simple. And so depending on your strategy and your failure, let's say toleration, we can determine to go forward or not, right? And yeah, so at the moment it's all or nothing, just to have to have a baseline, and then we can add additional capabilities along the way, right? And the way we would control it is through that rollout CR. So there is a strategy into the CR, right? That is going to determine what strategy to follow, right? And yeah, probably we need to have some different flavors there to actually see what are all the options that we need to have, right? But yeah, so basically, also here, so I'm of the opinion that if you do one thing and one thing well, right, so you basically make it rather simple, and you can explain what this thing is doing, right, easily. So in other words, it takes the rollout CR based on the strategy that it was applied, and then executes it, and it determines success or failure and reports upon it. That's kind of what happens, right? And so
Sorry, quick question. So when it's doing the network-wide transaction, how is it doing that in terms of how it connects to the devices? Is it doing them all in one go, or is it doing them in serial? Sorry, is it doing them in parallel, or is it doing them in serial? Or
parallel? At the moment, parallel. So it's all Go routines in parallel.
So if it could be the case that it rolls out config to a bunch of devices. It's fine, but one device fails, and then it's going to go back and roll back all of the rest of the devices that it rolled out to. Yeah.
Yes,
okay.
yeah. That's what it is right now. Now, this is where I'm saying we can do other stuff, right? So we can say network-wide, but do it sequential, right? So this is where strategies, what for me is determined by the strategy, right? I just said, okay, let's start with something because then we have something. But the idea here is based on strategies to give more flexibility, right?
Yeah, makes sense, yeah.
And you can influence the rollout based on this rollout CR, right? Which is, so we have to probably determine the type of strategies that we want to support and then implement those, right?
Do you think it would be, so the rollout CR is created by the controller?
Yes.
Yeah.
By this guy, but it takes it, so if it's in Git and you do roll forward, it takes what is in the Git repo. So you have full control over what it is.
Yeah. Yeah, I was thinking, would it make sense to, is it possible to influence this rollout, not necessarily by a file in the repo, but by something in the change itself, in the MR, for example, or the PR? Because I see from another system where I work that we do it on a per change basis. So we might have a really simple kind of BAU change where we say, okay, we just roll this out. We think it's highly unlikely to fail. We just roll this out. But the next change might be more complex and we want to do a gradual rollout.
It is per change. It is per change then, right? So in other words, so every of these changes will be, so let's say let's focus on roll forward. So in other words, per MR or PR, you can have a different rollout CR. You see?
Yeah. How would you? Yeah. Okay.
Check that you check that in as a file, and you can change it on every commit.
Oh yeah. Okay, I get you. Yeah.
Yeah. And maybe that's what I was envisioning. Maybe this is not, So in other words, you have a file in the Git repo that determines how you're going to roll this out. That's basically how I envisioned it. So that
and
file
you change it on every MR, or when you need to, then
Yes, yeah, correct. So
there
per
is
MR you
there is
can
an issue. There is an issue with this concept. If you roll back, not
no. So that's
like
why I said rollback. Rollback always uses network-wide transactions. So I'm not looking at that CR. Does it make sense?
like the all parallel stuff. Okay.
Yeah. So I use the default. So at the moment it's network-wide, but we could have other. The default we can change it, right? And maybe that's also influential. I don't know. I mean that we can influence that. So the way to do that would be through the workspace, because the way you do rollback is you actually update this CR, right? So we can also add something in here that says if you do rollback, use this strategy. So we could also influence that if you want, right? If that makes sense.
Yeah, kind of. So if you supply this CR with a rollback CR with a different strategy,
then I will take that.
Then you're still gonna but right now it would use well.
Right now I do a default because I just I want to make all these strategies add complexities to the code. So I'm just trying to get something working as a base, and then we can add more capabilities to it.
Yeah, but it seems like by default doing a rollback with a network-wide transaction makes sense, right? Because if you have a strategy like gradual rollout, for example, where it batches changes, then if something fails, you just want to get back to the previous state as quick as possible, rather than use the actual strategy that you wanted for the rollout itself. Yeah.
Correct. Yeah. Or maybe the other option is that we have a roll out and roll back in the CR, right? So that's the other option you can do.
Yeah.
I'm just yeah, I want to do this in a collaborative way, right? So that we discuss how people want to use it, because yeah, this.
Yeah. I suppose the tricky thing is where you have jobs coming in a short space of time, and one strategy is kind of gradual, and then another one comes in behind it that's a network-wide rollout. It's how do you kind of have the two running? I suppose you just have to run them in sequence, right? So you would still have to wait for the gradual rollout first to complete before you would do the network-wide rollout. Otherwise, you
So at the moment, at the moment I do them in
together.
sequence. Yeah, at the moment I do them in sequence. Yeah. So in other words, if you would update the workspace PR, right, and there is something ongoing, it will not update it unless it's finished.
Yeah.
And that can be both failure or not, right? So I don't care whether it fails or not. So I just go and take the next thing, right?
Yeah, makes sense.
It's sequential. Yeah. I mean, we can change. So we can. Yeah, I think we have to start with something basic, right? And then we can add stuff to it and get some feedback and see how people look at it, and we can enhance it, right?
Yeah.
But yeah, so we have not tested. So we first implemented the transaction interface between config server and data server. So that's now there. So now I'll wire this up, and so probably in the next, if you're back, maybe then after next week, we might have something that you can test with.
Okay, cool. Sounds good.
Because actually, most of the code that I put here is done. What is not done is the Git controller. I thought, because at the moment, so the reason I did not implement it yet is I said, so at the moment, the way it works is you have to manually, so you manually apply it, right? So in other words, you do a YAML. So basically, the way I'm testing it at the moment, I'm adding new Git repos, right? So I do MRs or PRs and what have you, and I just change the reference, right? And then I update it, and then I see what happens, right? So that's how I test it. So it's easy to test for me. So that's why I also said, okay, maybe this guy can wait a little bit for now, right? So let's first do it manual, and then we can see how we wire this guy up, right? But yeah, so the way I'm testing at the moment is I'm actually, I'm having a repo, and then you see, so actually, if you look to this repo, that's my test repo. So you can actually have a look at it.
Yeah.
And I am just testing some scenarios just to see how it goes, right? And yeah, so all that interface seems to work. But okay, there's all these corner cases that need to be tested. But
sure.
Yeah. But yeah, I decided for the time being to keep it manual, such that, okay, you then have more control as well, right? So you kind of have a little bit of how it goes.
Yeah, makes sense. There's a lot of moving parts, right?
Yeah. Yes, Sriva, I think you had a question, right? During network-wide transaction, I understand the chains are happening in parallel. Yes, at the moment, that's what I did. And while multiple transactions are instantiated, the order of transaction preserved. Yes. So in other words, the way you actually have to look at it, the way the system works right now is that a workspace update is kind of new work, right? And that will be, so the work that was triggered will be executed by the rollout controller. So the rollout controller is the one that executes the work, if you will. And there is no new work scheduled at the moment unless the rollout finishes its job, right? So that's kind of the way it is. So in other words, yeah, it is sequential. Now, what happens in the system at the moment is that, let's say you do, so the assumption at the moment is, and that's also probably an interesting discussion. I see the Git repo as evolving, right? So that means, so what can happen with the current system is that, let's say you have three, I don't know whether it's realistic, but in theory it could happen, right? So let's say you do 3 PRs or you do 3 changes. If you update the workspace PI, the workspace with, let's say, first reference 1, and it is still busy, so it's busy rolling out its stuff. You update 2, and it was busy, so it doesn't schedule it. In the meantime, you already update 3, it will never execute 2. So it will go to 3, which means somehow that the assumption is that 3, from the moment 3 happens, it incorporates 2. Or they have to happen in sequence. So you cannot do 3 unless 2 happens. You see what I'm saying? Does it make sense? Okay. So in other words, you can skip, so it will always take the latest. But so what it means in essence, and okay, that's also a little bit based on my philosophy on how Choreo actually works, is that it updates, so it basically creates new changes. And I also believe that because of the merge strategy that we discussed on the chat, Dan, right, is that we said, so somehow this whole thing needs to happen in sequence, right? So there is somehow a sequencing here that is now based on the merge, because otherwise you can have merge conflicts, right?
Right. Yeah, I understood.
Yeah. So we could, we can see whether we can do some other stuff, but yeah. So that's how it is at the moment. All right. I think that's all I had. I don't know, there is other questions or not. If not, and thanks for it. So we are in the process of releasing all of this, right? So basically the actuator will come next. So we'll first do a cut, right? And then we will add the actuator. So I hope we'll do something. I will have something when you're back then as a basic. And then maybe others can have a look at.
Yeah, great.
Sounds good. Yeah. And then if other people want to look at these discovery profiles for other vendors, by all means, we could use some help if people want to discover Juniper or Cisco or others.
Yeah, I think my loose plan was to get SR Linux and Arista,
and Arista,
and then Juniper, because we have all 3 in our network, but Juniper is the least. So I'll add that in afterwards.
Yeah, sure. It would be great that people can do it, and also then we get some feedback how easy or flexible it is and stuff like that, or not, and then we can update it. All right, cool. Thank you, and thanks for the session. And we'll be in touch.
Thanks, guys.
Then,
cheers.
Yeah, cheers. Bye.
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 Thank you. Bye.